So let's say you wanted to know something about all EMU students, maybe the way they believe or the way they perform on a certain test or sport or something like this. And we wanted to know an average for all EMU students. In descriptive statistics, we could just get data on every single EMU student, and then um, we would know the answer to that question. In reality, that's very hard to do. It's expensive, it's time consuming, and so instead we take a sample of a smaller group of EMU students, hopefully one that's representative of all EMU students. For example, a random sample or some other sample that we feel is representative of all students, get the data on them, and then we generalize it to the entire student population. This is known as inferential statistics because we're making an inference or a guess about all the wider population. So with any type of guess, you can always be wrong, and that's where inferential statistics gets a little sticky. It's much more cost effective, but we always have to remember there's a chance that the results aren't completely true. And we'll get into confidence intervals here fairly soon that handles that situation. So if we wanted to get a representative sample from EMU, of all EMU students, and we wanted to know about enjoying cross-culturals, if males enjoyed it more or females enjoyed it more, and we were to ask the first 20 people leaving chapel, would this be a representative sample? Probably not. For one, I mean, it could be that the first 20 leaving are all male or almost all female. It's also very possible that the students who are attending a chapel at EMU are not necessarily representative of the broader EMU student body. So you wouldn't necessarily get a sense of, in general, what the EMU students feel. This would be a little better because you would make sure that you would have at least 10 males and 10 females, but you still have the bigger issue of the students attending chapel are not necessarily have the same views about cross-cultural as the students in the broader campus. Drinking 8 ounces of water and 20 of your friends do it. If you were going to do some kind of political survey or something on a controversial topic, it would not at all be a good idea to have your friends answer it. That's a convenience sample that's not going to be representative of the student body. Drinking 8 ounces of water is a little more unbiased. It's still a little questionable because you might have, maybe you're on the baseball team and you have 20 baseball players who can guzzle 8 ounces of water really quickly. So it's a little better than a political issue, but still questionable in terms of representing all EMU students. Another issue would be if you were asking about sports, movies, or humanitarian issues, and you were just asking everyone in this class. Well, the problem is the majors that require stats are not necessarily the same as the majors that don't require stats. And so again, this would be hard to get a representative sample. Really, the golden standard is a random sample. That's really how you get a representative sample, so that whatever results you get from your sample can validly generalize to the broader population. So an observational study or survey, the idea is to capture whatever the natural response is. Instead of putting something in a laboratory or a fake environment, you want to capture data as it really is playing out in the world. This is good in the sense that it's much easier to get a random sample when you're just going to be doing observations or a survey versus actually manipulating somebody or having them do certain things out of the ordinary routine. So it is easier to get good random samples and thereby good generalization of your results to the whole population. However, the huge issue with observational studies or surveys is the lurking variable. If you're trying to show that something causes something, for example, coffee causes high blood pressure, and you look at all these coffee drinkers and compare them to non-coffee drinkers, and then you measure their blood pressure. The problem is coffee drinkers in general might be very different than non-coffee drinkers. So there could be all kinds of lurking variables that make it hard to say that one thing is causing another. And that's why we have experiments. So experiments intentionally go after this question of something causing something else. And they use randomization, but they use it in a different way than what we just saw with random sampling. Random sampling is pulling randomly from the population so that your sample represents the population. So what that allows you to do is whenever you get your study results, whatever they are can probably generalize out to the population. This is a different type of randomization here in an experiment. You get the sample, however you get them, probably not by random sampling, probably by convenience sampling or 20 of your friends or something like this. And then you randomly assign a portion of them to the treatment group or one of the treatment groups, and a portion of them to a control group or other treatment groups. But they don't get to choose which group they get in. That's randomization. The whole point of that is if there is a difference then between this group and this group in the outcome, it's probably not because of intelligence or looks or ability levels or experiences, because randomization is going to make all of those things, all of those potentially lurking variables, roughly balanced. The only thing different is going to be that these people all got the treatment and these people all didn't. So if you do see a difference in the outcome, you can say it's probably the treatment that caused that difference in the outcome. So experiment is very powerful in terms of showing that one thing causes another. And it's because of that random assignment is what makes the experiment powerful. So you're getting randomly assigned, like I said, to one of the treatment groups because it's balancing out almost every variable. If you want to think about social life, well, the people with good social life are going to get split up randomly into the two groups. The people with depression are going to get roughly split up. Who are very lonely are going to get roughly split up, so that almost every variable is roughly balanced, except for everybody in this group gets the treatment, everybody in this group doesn't. So you won't necessarily even know when you're doing the experiment what the lurking variables are. That's okay, because they're balancing out, so they're not impacting the differences in outcome, or at least not nearly as much as they could in an observational study or a survey. So then if they're so good, why don't we just do away with observational studies altogether? Why shouldn't we just always do experiments? Well, the big issue is that random assignment process. It's not always easy to do, and sometimes it's not possible. Sometimes it's not ethical. Think about this. Are people with blue eyes more predisposed to alcoholism? So our explanatory variable here is eye color, blue eyes. So can we randomly assign someone to an eye color? You could put in colored contacts, but that doesn't necessarily, that's not the genetic print. So we couldn't randomly assign someone to eye color. Does a person's race affect their ability to get hired? You can't randomly assign someone to race. Does how much sleep you get before a game affect? Now, maybe you could randomly assign, but if the competition was high stakes at all, you'd probably have a hard time convincing the coach to let certain athletes only get a couple hours of sleep just to see how your study would turn out. So here we're getting into some logistical issues. Does the SAT or ACT better measure college GPA? Now, this one potentially you could do. You could randomly assign people to take the SAT and another group to take the ACT, and then measure their GPA. Maybe. College entrance is a private, personal type of decision, but this is something that could be randomly assigned. A medical treatment for a life-threatening disease. So could you randomly assign half the people to get this treatment and half the people to get a placebo, an empty drug that doesn't really do anything? That's dangerous, and especially for a life-threatening disease. So what they do, they want that random assignment when they're dealing with medical treatments, but it would be unethical to give half the people this empty placebo. So what they do is they randomly assign half the people to get whatever the current leading drug on the market is, and then the other half get this new experimental drug. So you're either way, you're probably getting a decent drug for the life-threatening. No one's getting a placebo if it's a life-threatening disease. If it's just a skin cream to see how soft something is, something like that, then you might have a placebo in that case. This one would be really hard. Religion, and you're trying to give people more joy, but not impossible. I guess if you had people who were willing to wholeheartedly embrace a religion for a year, and they would get randomly assigned to one of these three, and then you measure their level of joy, it'd be a little weird because it's hard to like control your beliefs. But as long as we're just talking about attending the services, the small groups, the prayers, that kind of thing, potentially you could do that for random assignment. But in many cases, the point is, in many cases, random assignment is not possible, and so we have to go with observational studies. Now remember, one advantage of observational studies and surveys is they are easier to take random samples, so you do get better generalization of the results than you do with experiments. But in terms of figuring out if something is causing something else, experiments are still going to be by far the easiest.